Problem number 3. We're given an ellipse with this equation. We're asked to find parameterization and an arc length parameter. So the equation of the ellipse is 25x squared plus 9y squared is equal to 225. We're told for a parameterization, r of t is a cosine t, b sine t, where t is running from 0 to 2 pi. So I think the easiest way to find a and b is to plop in a cosine t, b sine t up here into this equation. So we get 25 times a cosine t squared plus 9 times b sine t squared is equal to 225. Okay, what do we have? 25a squared cosine squared t plus 9b squared sine squared t is equal to 15 squared. So the thing that we would like is we would like this whole thing to equal 15 squared here. Well, we know that cosine squared t plus sine squared t is equal to 1. And so the question is there a way to choose a and b in order to get this to be 225, 15 squared? If we set, let's just try the following here. If we set a is equal to 3, why did I choose 3? Because I can get 25 times 3 squared, 25 times 9 is 225. So 225 cosine squared t. How do I get to 225 from 9 times b squared? I think if we set b equal to 5, then we would get 9 times 5 squared, 9 times 25 is again 225 sine squared t. And sure enough, that is equal to 225 times 1, which is 225. Hooray, that takes care of the first part of the problem. So we can choose a is 3 and b is 5. Okay, so secondly, we need to figure out the arc length parameter here. What is that c of u? S of t is the integral from 0 to t of c of u du. So we should remember that we get to this by the speed. So r of t is this. R prime of t is going to be, take the derivative here, negative a sine t and b cosine t. Of course, we should feel comfortable plopping in a and b at this point. Negative 3 sine t, comma 5 cosine t. And the speed of this, the magnitude of r prime of t, is the square root of the first component squared, negative 3 sine t squared, plus the second component squared, 5 cosine t squared, and this ends up as the square root of 9 sine squared t plus 25 cosine squared t. Okay, and so then this is the thing that we need to plop into our arc length integral, our arc length parameterization. S of t is then the integral from 0 to t of so it says c of u here, so we need to convert, we just need to plop in the speed here, but write as a function of u. So 9 sine squared u plus 25 cosine squared u du. This is all I'm asking you for as a final answer here in this problem. Okay, so that was problem number 3. Let's take a look at problem number 4. Consider the vectors v is a, 1, 2a, and w is 1, 2a, a. A is some number. We want to find the angles of A, which guarantee the angle between vectors V and W is obtuse. So V is A, 1, 2A. W is 1, 2A, and A. So the thing to realize here when we're talking about obtuse angles, that means the first thing we should be thinking about is the dot product. So before we do anything else, let's just write down what is V dot W. So V dot W here is A times 1 plus 1 times 2A plus 2A times A, 2A squared. So this is 3A plus 2A squared. Okay, so now going back to, acute and obtuse, remember something that we should know here is that, so our angle could either be acute, less than 90 degrees, less than pi over 2 radians, right, exactly pi over 2 radians, or obtuse, bigger than pi over 2 radians, and we get that from the dot product. Acute means the dot product is positive, right, orthogonal, V dot W is exactly equal to 0, and obtuse means that this is negative. So really the thing that we are being asked to find here is, this is now just the question, when is 3A plus 2A squared, when is this negative? Okay, so the way to analyze this is, let's factor out an A times 3 plus 2A. We want this to be negative. Now, first thing to realize is that if A is positive, if A is greater than or equal to 0, then this term will be positive and this term will be positive. So let me just make a little sign chart here. So if A is bigger than 0, everything inside is positive. If A is less than 0, of course that term will be negative. 3 plus 2A here, well, we have to worry about, is that term positive or negative? So 3 plus 2A, when is that equal to 0? 2A is equal to negative 3. A is equal to negative 3/2, so let's put in negative 3/2 on our sign chart. And so the thing to realize here is that if A is less than 0, but at least negative 3/2, this term is negative, this term is positive. So that's what we want. But if A is less than negative 3/2, both of these terms end up as negative. Multiply them together, get something positive. So we can see here the only allowable values of A. The only allowable values A here that make this quantity here negative are A is between negative 3/2 and 0. So there's kind of two parts to this particular problem. One part is doing all of the sign analysis to figure out when is sign chart stuff like that here, when is 3A plus 2A squared, when is that negative? But the more important, the multivariable calculus part of this problem is knowing that when I'm asking you about when is the angles between those vectors obtuse, knowing that that means that the dot product has to be negative.